Hi everyone. So far we have been using images provided by someone else, either by Matthew or by an organization as Debian, as Python. Now it's time to see how to create your own images, such as you can store them either in the Docker Hub or in a different registry. And the way to do this is using Dockerfiles. Let me say that Dockerfiles work with both Docker and Podman, because we explained it at the beginning in the first chapter about the Open Container Initiative. So it doesn't matter if you're following this tutorial with Docker and Podman, the instructions are the same. But both use Dockerfiles. We will explain what is a Dockerfile and how the images are built. And the objective at the end is that you will create an image from the example that we have been using so far. So let's start with explaining basically that the image is a static file that contains the template to create the container on the machine. The engine that you're using will pull the images from repositories, from registries, or from your local storage, and then we'll create a container from that. We have been doing this so far. The container engines can also build and save into a repository the images that are being created, either by hand or either automatically, outside of the scope of this tutorial, but you can use continuous integration to do that, for example. If you are interested, you can look at the continuous integration tutorials that we have in the IRIS-HEP or any tutorial available on the internet. Let's start with our example, and for this we will create a new file called Dockerfile. This Dockerfile will contain the instructions to create a new image from the image of Matthew that we have been using so far. And the goal will be to add to the image the command co-say and the library scikit-learn. So once open your Docker file, we can start with a comment just to specify this is a Docker file, and we will have to do the command from just to indicate Docker or Podman what is the base image that we will use. In this case, we will use the image that Matt provided, intro to Docker. Now let's use the tag latest. Now you can provide a user to perform the operations. In this case, since we want to install things inside the container, we will use root. And then we have to specify the commands that we want to execute. So for this, we will use the command run. And since the image of Matthew is coming from Debian, we will use apt-get to install. So first, apt-get update. So this will just update all the different, all the information that is available for apt-get locally before performing any other operation. Then let's do apt-get upgrade and apt-get install co-say. So far we have been just updating the information that the package manager has in the repository, and after that we will install the co-say. You may be wondering why these symbols. Every time that you use the command run, the engine will create a new layer for the image. And in this layer, there is a new pipe that will execute the command. If we simply use run for different lines, we will have different layers of the image. And it's easier to compress if we use just one run to execute multiple commands. So that's the reason why we are using a symbol to specify different commands in different lines. One more important thing is that, for example, if we create variables during the run and we use run in the next line, the variables that we created will not persist for the next run. So just keep that in mind. So it's a good practice to keep the commands in a single layer. let's save some time copying what we need. So another important thing is that you have to do some cleaning after installing something. You don't want to keep the image too big, just keep what is needed to execute the container. So it's a good practice to always use the commands to clean after installing. Now let's add a second run just to install the second package. Scikit learn. Okay, so these two runs will just install and then clean after the installation. That is two layers of in the image. After that, we need to specify a working directory. So far, we have been saying the image has a working directory. Every time that I access or I execute a container, I start in a directory. Well, this is specified with this work dir. And let's say we specify home docker. And you need to provide a user after you are done with all the operations. Otherwise, the container will be executed as root. And this is a bad practice. It's better to use a different user other than root to continue with the work. So in this particular case, we can say Docker, or you can name it as you prefer. Once your Docker file is ready, we come back to the terminal and we can use Podman to create our first image. So we do Podman build. We have to provide the file, in this case the Docker file that we just created, and we have to specify name and tag for the image. So we are just extending the example, so let's call it extend example, and we have to add a tag, and I want to save my image in the local directory. Once we do this, we will see that Podman will start to build the image from the commands that we specify in the Docker file, and we have to wait a bit until it is done. Once the execution is done, we can check that the image is available. So this shows extended example, it's available there. And we can create a container from the image. So let's use Podman run. We don't want to keep the container after we are done. We want an interactive session, and we want to use the extend example with the tag latest. And we want to run bin bash. So let's see, we are actually in the working directory that we specify in the Docker file. And let's just run the command say that is already available there. So hello from inside the container. So as you can see, the image already contains the instructions to install say. So by the time that we run the container, the command is already available. We can also see that the scikit package is available. So if we do pip list and we search for it, and this was not available before in the first image that we use to build containers. A few words about tags. Tags are simply labels that are meant to identify images, and the images can have multiple tags. So as an exercise, use Podman tag to provide a new tag to the image that you just built. The solution is there, but try to figure out by yourself how to use it. There are many commands available for Dockerfiles. You can look at them at the Docker documentation. Let's look at another one that is useful for the common workflows, that is copy. Copy will just take one file on the host and we'll insert it into the container image. Just as it illustrates here, copy, just specify the path on the host, and then where do you want to locate it inside the container. For example, let's say we can create a file that contains instructions to install a package. So for that, let's create install Python dependencies. Let's use the same name as an example. If we just copy the example just to gain some time. So this will just install tools that we require to work inside the container, for example, and also the scikit learn package using pip. So these are the instructions located inside this bash file. Let's just create a new Dockerfile. Dockerfile, in this case, we'll name it copy, just to indicate that this is a Dockerfile, that it's modified in order to copy the file that we just created. So it's similar to what we did before. The only difference will start here. So let's just copy from here, because we already explained what all that lines do. And let's add the new line copy that will indicate I want to copy the install Python deps that is located in the host inside the image. And then let's indicate we want to run these instructions using bash. And we will just remove it to keep the image as small as possible. And because we don't need it after we build the image. And the rest is the same. Once this is done, let's build again our image. In this case, we will use dockerfile.copy. We want to name it as copy example with a tag latest, and let's indicate that the build context is in the local directory. And again, we will have to wait until this is done. Once the build is done, we can take a look at the log. We can see that the copy was successfully done. We can see that the file is being executed using bash. And we can see that the packages are being installed. As an exercise, try to build a container from this new image that we just created. You can see that the copy example is available. It indicates that it just exists in the local host. This was not coming from the Docker Hub as in the other cases. So exercise a bit and try to create a container using this image and see that the dependencies that we just installed are actually available.